This section examines crank angle sensing. Crank angle sensing uses information on the speed and position of the crankshaft to control ignition timing and injection sequencing. The control unit can then trigger the ignition and injection to suit operating conditions. The position sensor may be mounted externally on the crankcase wall, or it may be inside the housing of the ignition distributor. Inductive-type sensors act as a small alternator and generate a sine wave, alternating current voltage. The teeth on the flywheel ring gear can be used to induce the voltage in the sensor, inducing 1 pulse per tooth. The frequency of the pulse allows the control unit to detect engine speed, or RPM. Crankshaft position is detected by a separate sensor, also an inductive type. It sends a signal to the control unit when a pin or bore passes and generates 1 pulse per revolution. It signals the control unit that the number 1 piston is, for example, 80 degrees before top dead center. Ignition timing is then decided according to the operating conditions and triggered to occur a certain number of degrees from that point. When only one sensor is used, the pulse inductor is shaped to provide information on both crankshaft speed and position. A disc attached to the crankshaft pulley has a number of equally spaced ribs around its circumference, but 2 ribs are omitted. The frequency of the pulse from each rib gives engine speed in RPM, but on each revolution, the pulse alters as the gap from the 2 missing ribs passes the sensor. This again gives the position of the number 1 piston.